let's take a look at this example. We're supposed to eliminate coefficient 5 from the first log. How we can do that? By applying the property for the log of power. And this coefficient is going to be the exponent for my x. So I'm going to have logarithm x to the 5th power minus logarithm x to the 3rd power equals 2. Please notice that we have difference of two logarithms. Before you are going to go further, please look at the base of these two logarithms. These two bases are the same. There is invisible 10 and invisible 10 over here. So I can apply the property for the logarithm of quotient, which says the difference of two logarithms is equal log of quotient. So I can rewrite this as log of x to the 5th over x to the 3rd is equal to. By using properties of exponents, we are going to simplify the fraction in the parentheses, and this is going to be equal log x to the 2nd power equals 2. Next, I'm going to convert the logarithmic form to the exponential. Please keep in mind that this is common log, which has base 10, invisible 10. You have to make it visible and simply write 10 to the 2nd power is equal x squared. So, in order to eliminate this square, I'm supposed to square root both sides of the equation and simply write x is equal plus minus square root of 10 to the 2nd power. Square and square root will cancel out. This is going to be equal x equals plus minus 10. I got two answers. I got answer positive 10 and negative 10. Let's check how these answers are going to work with the original equation. Please keep in mind that the domain of the logarithm is supposed to be always greater than 0. So, for the first logarithm, right, if I'm going to use positive 10, the domain is going to be positive. For the second one, if I'm going to apply positive 10, the domain is going to be positive. So for sure, x equals positive 10 is the correct answer. Let's check negative 1. If I'm going to replace x by negative 10, my domain is going to be negative. This is going to against the definition. So this is incorrect answer for the first log. And if I'm going to raise negative 10 to the 3rd power, I'm going to get negative number anyway. And I'm going to again against the definition of the logarithm. That's why my answer for this problem is positive